Hello to all my Form 4 students. Today we are here to continue on the chapter Acids, Bases and Salts. We are going to do part 4 and I will be covering page 108 from this module and also page 112 from this module too. Okay, so we are going to discuss two subtopics today, which are how to write ionic equation and also how to calculate concentration for a aqueous solution. Okay, so let's start. So let's go to what is the meaning of ionic equation. So one thing I would like you to understand, what have I written here? Okay, what have I written here is chemical equation. This is chemical equation. Now, how to write ionic equation is, when you're writing ionic equation only considers particles which has gone through a change. Okay, teacher repeat. So, in order for you to write ionic equation, only particles which have changed, okay, during the chemical reaction is written in ionic equation. Okay, so I give you two examples on how to write ionic equation. Why? Because after this, the knowledge for you to write ionic equation will be very useful throughout the other chapters. Alright, okay, so please have a look at this. Sodium hydroxide reacted with nitric acid to produce water and sodium nitrate. Now what happens is, I have written separately the reactants and also the products. Now what you can see is, when you look at sodium ion here, before and after, sodium ion is the same. Meaning, maybe you can say does not change the oxidation number. But it's okay, don't worry about oxidation number yet. But you can say that even though sodium has reacted or combined with nitrate, it is still in a form of ion. So that is the reason why we can cut sodium ion. We can cut sodium ion at the product and reactant. Now look at nitrate ion. Nitrate ion, you can cut nitrate ion at the reactant and at the product. Why? Because both of them, at the reactant and product, they are same. Okay, they are still in ion form. Now, why I am not cutting hydroxide, hydrogen and water? Now, ionic equation takes into consideration particles which has went through changes. Now, here you can find hydroxide and hydrogen ion has combined, ions have combined to produce a molecule called water. So that is the reason why ionic equation for this reaction is hydroxide ion with hydrogen ion produces a molecule called water. Okay, so please remember, sodium and nitrate ion, even though they have combined with each other in the product, they are still in the form of ion. Their ion did not change. Can you see the ion on top did not change? Okay, so that's the reason why sodium and nitrate ion are cancelled out in order to, as a consideration for ionic equation. Now, let's go to second example. Nitric acid reacts with magnesium. You are familiar with this reaction. Nitric acid reacts with magnesium to produce hydrogen and magnesium nitrate. Now, if teacher write them separately, these are how the ions look like. Magnesium in the form of this one. So hydrogen produce magnesium ion and nitrate ion. Okay, now if you look at it, who has changed here? So you can find that nitrate ion has not changed anything. Can you see before and after? Nitrate ion is still the same. Okay, it is formed of ion. So you can cancel nitrate ion as a consideration for writing ionic equation. But look at hydrogen. Hydrogen has combined. Okay, so let me balance. Hydrogen has combined to produce hydrogen molecule here. So can you see there's a difference? That means the particle has went through changes. From ion has went into molecule. Now look at magnesium. Magnesium is a form of atom. Now it has changed into ion. So we can consider your magnesium has went through changes. So that is the reason why it is written, the ionic equation is this. Produces hydrogen in the form of molecule plus magnesium ion. So this is how you write the ionic equation for the substance. Okay, so please remember ionic equation is written from, it is actually derived from the chemical equation. So you can't produce ionic equation before deriving chemical equation. You must write down a balanced chemical equation. Then from there you find out who has changed. For instance, hydroxide and hydrogen ion, they are no more in the form of hydrogen and hydroxide ion. Can you see? So that is the reason why here hydroxide and hydrogen ion is taken into consideration to write down ionic equation. Why teacher have not chosen sodium ion and nitrate ion? Even though they have combined, but they are still in the ion form. Nothing has changed for them. Only thing is they have combined with some other substances. That's all. Now, let's look at here. Hydrogen ion has combined to produce hydrogen molecule. Can you see they are totally different? So, you can take hydrogen ion into consideration. Magnesium metal has changed into magnesium ion now. Okay, so that's the reason why hydrogen ion and magnesium has been taken into consideration to write ionic equation. Why? They have hydrogen ion has changed into hydrogen molecule. Magnesium atom has changed into magnesium ion. So that's the reason why it is taken into consideration. Not nitrate ion. Why nitrate ion not taken into consideration? Before also it is in the form of ion. After as a reactant, as a product, it is in the same state of ion. Okay, so that's the reason why nitrate ion is not taken into consideration. Now, class, so let's go to our second subtopic, which is involving a bit of calculation, which is called concentration in aqueous solution. So, concentration is actually the amount of solute. Okay, amount of solute, bahan yang terlarut in a solvent. Solvent is usually water. In chemistry, we usually say solvent is referred to water. So, when you dilute something, for instance, this is water. So, water acts as solvent. Water acts as solvent when you put maybe a spoonful of sodium chloride. Sodium chloride, which is salt. So, that sodium chloride becomes the solute. And after sodium chloride has happily diluted into the water, this is what we call by salt solution. Okay, so water is the solvent, bahan yang melarutkan. Solute is the substance that supposed to be dissolving in the water. Solution is after you dissolve your solute in water, the solvent, the last what you get. Okay, so the result, final result is actually the solution. Then from there we can calculate the concentration, where concentration is the quantity of solute. Okay, so now teacher already explained to you the meaning of solute. Solute adalah in Malay is bahan terlarut. So now we are going to calculate what is the quantity of any soluble solute. Okay, so now you have two units. Okay, so two units, which is gram per dm cube and mole per dm cube. Okay, so mole per dm cube and gram per dm cube are referred as concentration. So now we might be thinking, what is the, because gram no problem, mole you have learned in chapter 3. Now you might be thinking, where does the dm cube come from? dm cube is, this is how we change. So 1000 cm cube produces 1 dm cube. So now you can see 1 dm cube. So 1000 cm cube, because usually our liquids are calculated in cm cube, 50 cm cube of water, 100 cm cube of water. Okay, so that's how we are used to it. But now as a standard solution, okay, in chemistry, in order for calculation, we use standard unit, which is dm cube. So 1000 dcm cube is equivalent to 1 dm cube. Alright, now let's go to meaning of molarity. Molarity is actually the molar concentration. So what do they mean by molar concentration is definitely, from the word you can know that it definitely will involve mole. Okay, so molar concentration is molarity. So how would you find molarity is, molarity is equivalent to mole per dm cube, which is basically this unit. Okay, mole per dm cube. Okay, so that is actually how you find molarity. In fact, this formula we can arrange to find mole. For instance, mole is equals to mv. Okay, but we are dividing the volume into 1000. Why? Because usually the calculation of volume is usually said in the form of cm cube. Okay, so that's the reason why, in order to convert cm cube into dm cube, whatever volume given to you can be converted into 1000. So you just divide it with 1000 to convert it. Convert cm cube into dm cube. Okay, so I hope you can understand this. So again, molarity is equivalent to mole per dm cube. So molarity is molar concentration. So basically this substance, mole per dm cube. So mole is written as n, dm cube is volume lah. Okay, so now when teacher rearrange this formula, I get another formula. This is also one formula used to calculate mole. Okay, in chapter 3, you learn that mole can be calculated using mass per molar mass, volume per molar volume, and amount of particles with Avogadro constant. Correct? So this is what you learn in chapter 3. Now we have one addition or one concept or formula, addition formula on how to find mole, is where mole is equivalent to, but this involves liquid. Okay, so mole equivalent to molarity divided with volume. Times with volume divided with 1000. Why are we dividing with 1000? Because our volume are usually given in the form of cm cube. So in order to change the cm cube into dm cube, why? Because molarity is usually in dm cube, we have to divide it with 1000. Okay, so I hope you can understand. So let's go, teacher teach you or show you few examples on how to find concentration, how to find the calculation for concentration using both, okay, two units, which is gram per dm cube and also mole per dm cube. Okay, so let's do this together. So first calculation, find the concentration of 100 gram of calcium carbonate in 100 cm cube of water. Now can you see, even teacher used the word cm cube. So in order to convert your cm cube into dm cube, you have no choice to change the cm cube divide the cm cube into 1000. Why? Because we want the unit to be in the form of dm cube. Now let's start. Now I want the concentration to be written in the form of gram per dm cube. So what will be the answer? So gram is 100 gram. So you have 100 gram divided with 100 cm cube divide with 1000. I hope you can understand. So why divide with 1000? Okay, why divide with 1000? Because we want this unit is basically to change cm cube into dm cube. So you will basically get 100 gram divided with 0.1 dm cube. Okay, so the answer will be 1000 gram per dm cube. Okay, so when you're watching this video, you can use your calculator. 1000 gram per dm cube. So again, please remember, because the question teacher gave you in the form of cm cube, you always have to divide with 1000 first in order to change it into dm cube. Now let's go to mole. So since you know how to find mole, one of the way to find mole is molar mass. So molar mass is actually mass divided with the molar. Okay, so molar mass. So let's go to mole. So relative atomic mass calcium carbonate is 100. Okay, so that is actually the molar mass. Relative atomic mass for calcium carbonate, if you take your calculator and calculate, you will find the relative atomic mass for calcium carbonate is 100. Now, how do you find the mole? Okay, so 100 gram divided with 100 gram per mole. You get 1 gram per mole. This is your molar mass. Okay, so this is your molar mass. Now we are going to find the concentration. So 1 gram per mole divided with 0.1. Sorry, yeah. This is molar mass. Now we not yet find the mole. Okay, so mole equals to 1 mole. Why? Because this is actually mole. So mole equals to 1. You get 1 mole. Okay, gram per mole. So gram per mole, you get 1 mole a day. So I hope you can understand. So gram is the mass given. 100 gram per mole is actually the molar mass. So you get 1 mole. Now find the concentration. Concentration is going to be 1 mole divided with 100 divided with 1000. Why divide with 1000? Because we are going to convert cm cube into dm cube. So the answer will be 100 divided with 0.1 dm cube, which is 1 mole divided with 0.1 dm cube. So this is 10 mole. Okay, 10 mole per dm cube. Okay, 10 mole per dm cube. Yes, 10 mole per dm cube. So this is how you find the concentration. Okay, so teacher repeat. When you're finding gram per dm cube, you already have the mass. Okay, you just divide the mass with dm cube. So in order for you to change it into dm cube, you have no choice but to divide with 1000. Okay, so hope you can, when you're watching this teacher's video, you will have calculator with you. So you can calculate when I'm showing this. Alright, now second, I'm asking you the concentration in the form of mole per dm cube, where relative atomic mass for calcium carbonate is 100. Thus, the molar mass is 100 gram per mole. So what we do is, the mass given is 100 gram. You divide it with molar mass, which is gram per mole. You get 1 mole. So now you already get this already. So now you have to find the dm cube. Can you see? You have to find the dm cube. So 100 divided with 1000. Why? Because you have to find the dm cube. Then from there you will get the answer 10 mole per dm cube. So hope you can calculate this using the calculator. Okay. Now let's go to second. I'll give you another example. So concentration. Find the concentration of 0.1 mole sodium hydroxide in 1 dm cube solution. Okay guys, you see here. Here teacher already straight away give you 1 dm cube solution. So you don't have to susah payah. Okay, you don't have to sweat to go and find divide with 1000, no need. Why? Because it is already given in the form of dm cube. Alright, so this is very easy because mole is given. So all you have to do is 0.1 mole divided with 1 dm cube. So the concentration is 0.1 mole dm cube. So this is how you do. Now let's go to gram. Now you are supposed to change mole into gram. Just now gram you try to change into mole. Here you are going to change mole into gram. Okay, so you will know that relative atomic mass for sodium hydroxide is equals to 46. So I hope you can calculate that. Okay, equals to 46. So 1 mole will bring 46 gram. So now you only have 0.1 mole. So 0.1 mole is equivalent to 4.6 gram. Okay, so teacher repeat. Relative atomic mass for sodium hydroxide is 46. 23 plus 16. Okay, 23 plus 16 is it 46? 1. Sorry, 40. Okay, 40, not 46. Sorry again. It is 40. Okay, so the relative atomic mass for sodium hydroxide is 40. So that means in order for you to hit 1 mole, you must have 40 gram. So now you only have 0.1 mole. So that means sodium hydroxide is only 4 grams. Okay, now, so can you see you already change it into gram. Now you already get the mass of the sodium hydroxide already. So next what you do is 4.0 gram divided with 1 dm cube. Why? Because you don't have to change anything because it is given in the form of dm cube for you already. So the answer will be 4 gram per dm cube. So this is the answer. Okay, so teacher repeat. Okay, because I made a mistake here. So let me rectify again. Now, mole per dm cube, you don't have to do anything. Why? Because look at the question. 0.1 mole with 1 dm cube. So straight away you just divide it. Mole, you divide with 1 dm cube, 0.1 mole per dm cube. Now let's look at, now you are going to, they are asking in the form of gram per dm cube. So what would you do is, gram, you have to no change, you have no choice but to change your mole into gram. So how would you do this? You get the help of mole calculation, mass over RMM. Okay, mass over RMM, where 1 mole is equivalent to 40 gram. Okay, 1 mole equal to 40 gram. Why? Because the relative atomic mass for sodium hydroxide is 40. 0.1 mole is equals to 4.0 gram, 4.0, 4 gram lah. Okay, 4 gram. Now, what happens is 4.0 gram divided with 1 dm cube. For dm cube, we don't have to do anything. Why? Because it's already given in the form of dm cube. So, you get the answer 4 gram per dm cube. Okay, so I hope you can understand, even though it's a bit complicated. You just watch teacher's video again and again, and please look at the other examples given in your page 112 in your module. Okay, page given in page 112 of your module for further understanding. Okay, so I hope you can understand what have I told you. We will continue in our part 5 video much later. Okay, till then, thank you for watching. Bye.